Hello, everyone. This is the Morningstar Institute 2022 Winter Week 5 Day 1 solution video. Problem 1. Use the vertical method to compute the following by carry and borrow. So let's look at the first equation. We know that 4 plus 7 is equal to 11, but since we can only put one digit here, we put one of the ones here and carry the other one over to here, because we can't put two digits in one box. So therefore, we now compute this and we add a 1 to the following equation. 1 plus 3 plus 5 equals to 9. So this left box should now be 9. So the answer for number 1 should be 91. Problem 2. Let's do 5 plus 9 first, because we always start from the right first. 5 plus 9, as we know, is 14. And since we can't put two numbers on the same box, we put 4 here first and carry the 1 over here. And we solve the equation. 1 plus 2 plus 4 is 7. So therefore, we write 7 on this box. So the second equation should be 74. And the third equation is the same, but this time we have to subtract it. And since we can't subtract 9 from 5, since 5 is smaller, then we have to borrow a 1 from the left side. So we can cross out the 4 and now write a 3 and carry it over. So now this 5 becomes a 15. And we know that 15 minus 9 can be minused. So 15 minus 9 is 6. So we write 6 here. And then we move on to the left side. 3 minus 1 is 2. So you write 2 on the left box. So therefore, the third equation should be 26. And finally, for the last equation, we see that the right equation, 6 cannot be minus from 0. So therefore, we need to carry another 1. We cross out the 9 on the left and turn it into 8 and carry the 1 over here. And then the 0 becomes 10. So 10 minus 6 is 4. So we write 4 here. And then 8 minus 4, as we can see over here, and that should just be 4. So the fourth equation is 44. Problem 2. In the story of Journey to the West, the Monkey King, the left one, could perform 72 transformations, and his helper Zhu Bajie, the right one, has 36 transformations. How many more transformations did the Monkey King have than Zhu Bajie? So as we can see, the Monkey King, which is the left one here, did 72 transformations, while the right one, Zhu Bajie, did 36. So all we have to do is subtract 36 from 72 to get our answer. So 72 minus 36, this should be very easy, 36 transformations. So let me just write that, transformations. And so we know the Monkey King did 36 more transformations than Zhu Bajie. Problem 3, put the greater sign, less than sign, or the equal sign in the circles below. For the first equation, we see that 4 plus 67. Well, we know that 4 plus 67 should be 71, and 22 plus 46 should be 68. So we know that 71 is greater than 68. For the second equation, we see that 15 plus 37 is 52, and 29 plus 23 is also 52. So therefore, this is equivalent sign. The third equation, 25 plus 12 is 37, and 80 minus 42 is 38. So therefore, 37 is less than 38. And for the fourth equation, 72 minus 35 is 37, while 60 minus 12 is 48. So therefore, 37 is less than 48. And for the fifth equation, 70 minus 23 is 47, and 30 plus 17 is also 47, so this should be equivalent sign, is greater than 48. Problem 4, 50 kids are playing in a park. After a while, some of them get into 4 boats on a lake. The others are playing various ball games on land. If each boat has 4 kids, how many kids are playing ball games? So first things first, we know that there are 50 kids in total. And after that, we know from part of the question that some of them get into 4 boats on the lake. So let's just pretend that these green circles are boats. And if each boat has 4 kids, so let's just draw 4 circles in each boat, we should get that there are 16 circles which are represented by kids. So therefore, 16 kids got into a boat. But that's not the answer because it says how many kids are playing ball games. So we should just subtract 16 from 50, and that should give us 34. So 34 is our answer. 34 kids are playing ball games for problem 4. Week 5, day 2, problem 1. Fill in the missing numbers in the table below. So let's look at this picture first. We have the minuend, which is 9, the subtrahend, which is 4, and the difference, which is 5. So first, let's see what the minuend is. The minuend is just the subtrahend plus the difference, or in this case, 4 plus 5. The subtrahend is just the minuend minus the difference, or in this case, 9 minus 5, and the difference is just the difference or the result, 9 minus 4. So now let's look at the graph. We are given for the first pair, the minuend 42 and the subtrahend 15. And what we get is just 42 minus 15, and that is equal to 27. So therefore, the difference is just 27. And next we have the minuend, which is 26, and the difference, which is 12. And as we stated above, the subtrahend is just the minuend minus the difference. So therefore, it's just 26 minus 12, and that gives us 14. And moving on to the third pair, we are given the subtrahend 35, and the difference 18. And as we have stated above, the minuend is the subtrahend plus the difference. So it's just 35 plus 18, and that gives us 53. And next, we are given the minuend, which is 50, and the subtrahend, which is 15. And we know that the difference is just the minuend minus the subtrahend. So it's 50 minus 15 equals to 35. So the difference is 35. And next, we have the minuend of 72 and the difference of 47. And we know that we need to figure out the subtrahend, and we know that the subtrahend is just the minuend minus the difference. So therefore 72 minus 47, and that just gives us 25. And finally, we have the minuend, which is 66, and the subtrahend, which is 52. And we can just subtract the minuend from the subtrahend to get our difference. And 66 minus 52 is just 14. So the difference should just be 14. And that's how you do problem 1. Problem 2, Jay's frog jumped 39 centimeters. Matilda's frog jumped 56 centimeters. How much further did Matilda's frog jump than Jay's frog? So let's label 39 centimeters first on a line. So 36, if 36 were somewhere here, then 56 should somewhere be right here. And all we have to do is calculate the difference. And this can be found when we subtract 56 from 39, and this should give us 17. So how much further did Matilda's frog jump than Jay's frog? The answer is 17 centimeters. Problem 3. Mario got $1 from the tooth fairy for his lost tooth. He bought one of the following toys and got 2 coins and change. Recall that there are 4 kinds of coins: penny, which is 1 cent, nickel, which is 5 cents, dime, which is 10 cents, and quarter, which is 25 cents. And also, we know that the ball at the bottom is 52 cents, the top 86 cents, the whistle 69 cents, and the car 72 cents. So we are given 2 questions. Number 1, which toy did he buy? And number 2, which coins did he get in change? First, recall that $1 is equivalent to 100 cents. And he bought one of the following toys. So all we have to do is subtract the price of that toy to the $1, which is 100 cents. So let's test out ball first, which is 52 cents. 100 minus the price, 52 cents, gives us 48 cents. And since he got 2 coins and change, let's see if we can play around with 48 to fit into 2 coins. And let's see. Well, of course, we have to plug in a quarter because that's the largest. And if we just do dime, then that's not enough. So let's see. 1/4, which is 25 cents, has to plus 23 to something. And we know that 23 is not a coin since there's no 23-cent coin. So therefore, we know that he cannot have bought the ball. So we cross that out. Next, if he bought the top, let's see. 100 cents minus 86 is 14 cents. And now let's play around with 14 to see if we can make 14 cents out of 2 coins. So let's see, this time we know that we cannot use the quarter since that's too much, and we cannot use the penny because that's too little. So therefore we must use nickel and dime. So let's use a dime first. We know that that's 10, and let's add another nickel to it, which is 5, but that gives us 15 cents, which is 1 cent more than what change he got. So therefore we know that he did not buy the top as well. So now let's look at the whistle. 100 minus 69, that gives us 31. And now let's play around with 31 to see if we can split into 2 coins. So let's look at the quarter first, since that's the largest. And let's see, quarter 25 has to plus 6 to equal 31. And since we know there's no 6-cent coin, we can erase that possibility as well. But hold on, let's look at another possibility. Let's look at the car now. 100 cents minus 74 is equal to 26. And let's see if we can put 2 coins in change with 26. So let's start out with a quarter. We can see that a quarter is 25 cents plus 1 cent equals to 26. And wow, a penny is exactly 1 cent. So we now know that a penny plus a quarter is 26 cents. So therefore, we know that Mario got a quarter and a penny as change. So which toy did he buy? We know that he bought the car. And which coins did he get in change? Well, we know that he got a quarter, which was 25 cents, plus a penny, which was 1 cent. 1 cent. Lucy can make 10 paper cranes in 10 minutes, and Emily can make 12 paper cranes in 15 minutes. How many more paper cranes can Lucy make than Emily? Half an hour. So let's look at Lucy first. Lucy can make 10 cranes in 10 minutes, while Emily can make 12 cranes in 15 minutes. And now let's look at how much they can each make in 30 minutes. So since Lucy can make 10 cranes in 10 minutes and 30 minutes is just 10 minutes plus 10 minutes plus 10 minutes, and each 10 minutes can make 10 cranes, then it's just 10 cranes plus 10 cranes plus 10 cranes equals to 30 cranes. And now let's see Emily. So she can make 12 cranes in 15 minutes, and 30 minutes is just 15 minutes plus 15 minutes. And each of 15 minutes can make 12 cranes. So 12 cranes plus 12 cranes equals to 24 cranes in 30 minutes. And now we know that Lucy has made 30 cranes and Emily has made 24 cranes. And the difference will just be 30 minus 24 equals to 6 more cranes made by Lucy. So the answer should be 6. Lucy can make 6 more cranes than Emily in half an hour. This is the winter week 5, day 3 solution video. Problem 1, fill numbers in the blank. For the first equation, we have 18 plus a number with 7 at the end equals to 60 something. Now let's start with the right-hand side. 8 plus 7, as we know, is 15. But since we have to carry over, because we can't fit 2 numbers on the same blank, so we carry 1 over to here. And this time we know that this blank, when added to the 2 ones above, must be 6, and that can only be achieved when we have 4 in here. because 4 plus 1 plus another 1 is 6. So we have 18 plus 47 equals to 65. The next equation is also the same. 35 plus 4, 40 something, is equal to a number with 4 at the end. And this time, we can see that 5 plus a number is equal to 4. But since we know that we cannot achieve this because we can't have negative numbers, so therefore we must have another rotation, and this time we must only have 9 because 9 is the only possibility, because we can see that 9 plus 5 is equal to 14, and the 1 is carried over to here. And when we carry over, we can just see that the equation is 1 plus 3 plus 4, and that just gives us 8. So 8 should be the blank. So the equation is 35 plus 49 is 84. And the next is something with 6 at the end minus 20 something is equal to 18. And we know that 6 minus something cannot be 8 because 8 is larger than 6. So it must be 16 minus something equals to 8. And therefore, we know that the blank should be 8. But then 16 has to be borrowed to another number at its left. So therefore, we know that this blank must be 4 because once it borrows, we know that it changes to 3, and 3 minus 2 is exactly 1 at the bottom. So therefore, the equation should be 46 minus 28 is 18. And the final equation, 70 something minus 46 is equal to something with 4 at the end. And we know that the first blank should be a 10 because 10 minus 6 is equal to 4. However, we need to borrow a 1 from 7 because 0 minus 6 cannot be equal to 4, 10 should be. So therefore, we borrow a 1 and 7 becomes 6. And 6 minus 4 is equal to 2. So therefore, the final equation should be 70 minus 46 is 24. And that's how you solve problem 1. Problem 2. Derek gave two $20 bills to a cashier to buy a toy. If he received one $10 bill, one $5 bill, and one $1 bill in change, how much did the toy cost? So let's first of all, let's define two $20 bills. Derek has two $20 bills, and that just gives us, he has $40. And now if he received one $10 bill, which would be 10, plus one $5 bill, which is 5, plus one $1 bill, which is 1, then that should just be $16 in change. So that means that we just have to subtract 16 from 40, and that gives us that the cost of this toy that he bought was 24. So $24 should be your answer. Problem 3. A math after school program has 100 students in 3 classes of different levels: entry, intermediate, and advanced. The entry level class has 35 students, the intermediate level class has 37 students, and how many students are in the advanced level class? So for this problem, let's draw a table. We know that in total there are 100 students, and we know that for the entry, there are 35, and for the intermediate, there are 37. And what we have to find out is the advanced. And now we can solve for the advanced because we know that what's left over is the advanced. So let's add together the entry and intermediate. 35 plus 37 is equal to 72. And we can find out how many people are in advanced when we subtract 72 from 100, and that just gives us 28 students left over. And from there on, we can just solve that there are 28 students who are attending the advanced class. Problem 4. Tim and Tom built a sandcastle and decorated it with a flag. They stuck half of the flagpole into the highest point of the castle. The upper tip of the flagpole was 80 centimeters above the ground. The lower tip was 20 centimeters above the ground. How tall was the sandcastle? Let's start off with this first. We know that this is 80 centimeters, while this is 20 centimeters. So we know that the height of this flag should be 60 centimeters. And since above it said that they stuck half of the half pole into the highest point of the castle, then that means that each part of this should just be 30. And this part, hold on, and this part in green should also be 30. And now we should know how tall was the sandcastle because we have 2 points. One, 30, and another one, 20. And 30 plus 20 should equal to 50 centimeters. So the sandcastle was 50 centimeters tall. Problem 1. The baker Smurf collected 33 cherries. He gave 7 cherries to each of his friends until he had less than 7 cherries left, which he kept for himself. We have 2 questions. How many friends had gotten cherries from the baker Smurf? And number 2, how many cherries did the baker Smurf keep for himself? We know that he gave 7 cherries to each of his friends, so all we have to do is see how many 7 cherries he gave out. Let's add a 7 plus 7 plus 7 first, and to see how much this is. And we know that 7 plus 7 plus 7 is equal to 21, and that's not nearly enough, so let's add another one. And 7 plus 7, let's add another one, 5 sevens together, and we know that this in total is equal to 35, but we know that this is not possible because the baker Smurf has collected 33 cherries, and this is 2 more than what he collected, so therefore this is not possible. And now let's subtract 1 7, and what we're left with is 4 sevens added together, and we know that this is 28 added together because 7 plus 7 plus 7 plus 7 is 28. And because he collected 33 cherries, we have another 5 left over, and this should be equal to 33 altogether. So from this, we can deduce that how many friends have gotten cherries from the baker Smurf? Well, the answer is just 4 because there are 4 sevens. And how many cherries did the baker Smurf keep for himself? And that's just in the green. How many that are left over? 5 were left over. So therefore, this baker Smurf kept 5 cherries for himself. Problem 3. We left for a summer camp yesterday at 4:32 p.m. and got to our destination today at 6:11 a.m. For how long did we travel? So they left at 4:32 p.m. And let's see how many minutes it took for them to get to 5 p.m. And that should just give us 28 minutes since there are 60 minutes in an hour. And now it should be very easy for us to calculate by the hours because it should be 5, 6, 7, 8, 9, 10, 11, 12. And starting from 12, it's now 8 a.m. So we can just write 5 p.m. to 6 a.m. And this just takes 13 hours. But we're not done because after 6 a.m., they have to drive another 11 minutes in order to reach the camp because they arrived at 6:11. So that takes them another 11 minutes. So we add the 28 minutes and the 11 minutes from before into the 13 hours. So 28 minutes plus 11 minutes, that just gives us 39 minutes to add to 13. So in total, they traveled 13 hours and 39 minutes. And let's see which one of the following letters represents that. And as we can see, number A is exactly the same as we had just solved. So the answer for problem 3 should be A, or in other words, 13 hours and 39 minutes. Problem 4. In a survey, 90 people were asked, what is your favorite pet? Their responses were recorded and then graphed. In the graph, the bar representing favorite pet as dog has been omitted. How many people selected a dog as their favorite pet? So in total, 90 people were asked. And since the dog was omitted, we can just solve how many number of people, other people answered as their favorite pet, and the remainder should be the number of people who said dog was their favorite pet. Let's look at cat first. We see that the number of people that answered cat is 25, so we write 25 here. The fish, as we see, is 10, the bird, 15, and other is 5. So let's add these together. 25 plus 10 plus 15 plus 5, and this just gives us 55. But there were 90 people who were asked, so the remainder should of course just be dog. So 90 minus 55 equals the remainder, which is 35 people. And that are the people who voted for dogs. So the answer should be 35 people selected dogs as their favorite pet. This is Winter Week 5, Day 5 solution video. Problem 1. Jenny arrived at the bus stop to find she had missed the 9:27 bus by 2 minutes and would have to wait for the 9:57 bus. How long will she have to wait? So since she missed 2 minutes at 9:27, then she arrived at the bus stop at 9:29, since she missed 2 minutes. And she has to wait all the way until 9:57 to get another bus. So we need to calculate the total number of minutes in between 57 and 29. And we should calculate 57 minus 29, and this just gives us 28 minutes. So Jenny has to wait 28 minutes for the next bus to come. Problem 2. Dan put all the numbers from 1 to 100 together to form a large number n. N equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 1, 1, 2, all the way to 9, 7, 9, 8, 9, 9, 1, 0, 0. How many digits of n are 1? So let's start off from 1 to 9 first. And we get that there is just one 1, and that is the number 1. And then we move on to a larger gap, 10 to 19. And this time it gives us a whole 11 1. And don't forget that the number 11 has 2 1s. And finally, from 20 to 100, we get that there is 9 1s. So you can just count it very easily. So in total, we have 1 plus 11 plus 9, and this just gives us 21 1s. So the answer is 21 digits of n that are 1. Problem 3. A spider was sitting on a ceiling. In some moment, it lowered itself 12 centimeters down, then climbed 7 centimeters up, and finally lowered itself 6 centimeters down. At what distance from the ceiling is now the spider? So let's just say that this blue dot is the ceiling. And in some moment, it lowered itself 12 centimeters down. 12 centimeters, and this blue dot is the bottom. And then climb 7 centimeters upwards. So 7 centimeters upwards. And now he is 5 centimeters from the bottom. And finally lowered itself 6 centimeters down again. So 6 centimeters is down. That would just give us 11 centimeters because he's already at 5 centimeters down from the ceiling and lowered itself another 6 centimeters down. That should just be 11 centimeters. So at what distance from the ceiling is now the spider? The answer is just 11 centimeters plus 5 centimeters plus 6 centimeters. So the answer is 11 centimeters. Problem 4. Find the smallest 2-digit number AB such that AB plus 27 is equal to BA. So first things first, let's start off with the right side in which B plus 7 equals to A. We know that B must be more than or equivalent to 3 because B cannot be less than 3. If B was less than 3, for example, 2, then we can see that 2 plus A equals to 2, and A must be 0 since there's no negatives. And we cannot do that because A cannot be 0. So therefore, 2 is not an option, and B must at least be 3. So let's try out 3. We can cross out B as 3, B as 3, and we can start off on the right side. 3 plus 7 is equal to 10, but this means that A must be 0, which is not possible. So therefore, we know that 3 is not a possibility. Next, let's try out 4. If we cross out B as 4, we can start off as saying 4 plus 7 is equal to 11. So we cross out A as 1, and we carry the 1 over here. And as we can see, 1 plus 1, because we carried a 1 and A is also 1. So 2 1s plus a 2 is equivalent to 4. And we have finally found our answer because we can rewrite this equation as 14 plus 27 is 41, or 14 backwards. So therefore, find the smallest 2-digit number AB. The answer should just be 14.